Today we're looking at Lesson 8.6, which is, generally speaking, factoring and solving polynomials, and it's in the form that is here, x squared plus bx plus c, where b is a number and c is a number. So we have d squared plus 11x plus 24. With any factoring, you're going to want to split the factored group or the polynomial into two groups. The groups will contain one of each of the first terms, because there's two terms there, and then the second two terms in each parentheses are going to be determined by what would you multiply together, including signs, to get the third term, so the 24, and what would you be able to then add together and get positive 11. So you want to think of factors of 24. Factors of 24 would be 4 and 6, 3 and 8, 2, 12, 1, 24, and that should be it. So you look at each set, and which set gives you a possible 11 when you add it together. Well, that would have to be 3 and 8, and you can keep them both positive. If you multiply 3 and 8 together, that's going to give you 24. So you put plus 3 and plus 8. And it doesn't matter which one comes first, but that would be how you would finish the factoring. So this would be your final answer. So we're going to do lots of those. So here's another one. I always like to put it in standard form before I start factoring. But we're going to think of factors of 9 that add up together to get 10. So factors of 9 would be 1 and 9 and 3 and 3. So the only one that gives us 10 when we add it together is going to give us 1 and 9. And we've split up our polynomial into two groups. We put our variable first, and then we have a positive 1 and a positive 9. And that would be our answer. Again, put this into standard form. So we're getting the factors of 21. Factors of 21 are 3 and 7 and 1 and 21. And so what we're doing is trying to get 22. The only way to do that is to use 21 and 22, but it needs to be negative 22 and positive 21 when I multiply. So that means both of the factors are going to need to be subtracting or negative. So I have m minus 1 and m minus 21. And the way that I'm explaining it is going to be a little different than the book, but if you use this method, it will work for any kind of polynomial. So it's a lot less to remember, so you may want to try it out. The next one is going to be starting with the w's. Then we need to get factors of 28 that add up to be negative 11. So again, 4, 7, we have 2, 14, 1, 28. So what we have in common here would have to be 4 and 7 that give us 11. And since it needs to be negative 11 when we add and positive 28 when we multiply them, they're both going to have to be negatives when we put them in. So we have w minus 4 times w minus 7. And that would be my answer. Continuing, we have y's this time. So we need factors of 48 that give us 13. We have 6 and 8, 2 and 24, 3 and 16, 4 and 12, and then that should be it. So we are 1 and 48. So we're going to pick which is going to possibly give us 13. Well, that's going to have to be 3 and 16. But it needs to be positive 13 and negative 48, which makes one of them have to be negative. So it's going to have to be the 3, because that's the only way to get 16 and 3 to be 13. So 16 is one of them, and that's positive 16, and negative 3 is the other. And again, just to reiterate, each time I do this, to check my answer, the numbers have to multiply together to get, including the sign, the third term, and they have to add together to get, including the sign, the middle term. So, negative 3 times 16 is negative 48, and negative 3 plus 16 is positive 13. Again, factoring. So we have our r's. We need factors of 24, 6 and 4, 3 and 8, 2 and 12, 1, 24, and we need to get negative 2. So we're going to have to use 6 and 4, and we need a negative 2 and a negative 24. So the higher number has to give us be negative, and the smaller number needs to be positive, because negative 6 plus 4 is negative 2, and negative 6 times 4 is negative 24, which is our goal. Here's another one. This one is asking us to solve. So first we need to move the 70 to be over on the same side as everything else, as the zero product property tells us. Oops. And we put it equal to 0. Then we need to factor the trinomial. So we need factors of 70 that add to get negative 3. So 1 in 70, 2, 35, 5, 14, 7 and 10, and that should be it. So which ones will give us negative 3? The 7 and 10 could possibly, so we're going to put those in. We need a negative 70 when we multiply, and a negative 3 when we add. So the 10 is going to have to be the negative 1, and the 7 is going to have to be the positive 1. So this is what we're solving. So we need to solve by putting each group equal to 0. So our answer is going to be positive 10 and negative 7. So z equals 10 and negative 7. So this would be our final answer, where we are asked to solve. Here they already have all three terms on the same side, so we're just going to factor and solve. So we have x and x. We need factors of 18. So 6 and 3, 2 and 9, 1, 18. And we need them to add up to be 3, but multiply to be negative 18. So that's going to mean we need 6 and 3, but we need the 6 to be positive and the 3 to be negative. So we're going to do x plus 6 equals 0 to get one answer, and x minus 3 equals 0 to get the other. So x would be negative 6, and x would be 3, so our answer would be negative 6 and 3. And one final problem here, we have the height of a parallelogram is 18 centimeters less than its base, and a parallelogram would be considered like a rectangle. If the area is 175 square centimeters, what is its height? So the area of a parallelogram is A equals base times height. So if the height is 18 less than its base, we need to write this as two groupings of terms. So the height is going to be represented with h, and so h is b minus 18. So if we put that all together, we have to put it all in terms of h. So the height is going to be h, and the base is going to be h minus 18. And then we're going to multiply that together. And that's supposed to equal the area of 175. So we have h squared minus 18h. And then we have to subtract the 175 to solve. But we need to factor this first. Two factors that would multiply to get 175 and add to get 18 would be 25 and 7. So we would have h, and it needs to be a negative 175 and a negative 18. So we're going to have to make the 25, the larger number, be negative, and the smaller number be positive. And then we solve for h. Now you can't have a negative number for h, so that solution doesn't make sense, so we're going to use the solution that gives us a positive number. So h would be 25. And that concludes lesson 8-6.